Hello children, in this video we'll discuss 5 activities of class 12. One is from chapter relation and function, one from inverse trigonometry, one from continuity and differentiability, and 2 from application of derivative. So let's try to understand one by one. So first activity is to verify that the relation R in the set L of all lines in a plane defined by R is equal to LM such that L is perpendicular to M is symmetric but neither reflexive nor transitive. First of all, we'll discuss reflexive property. In this we have taken one line. As we can see, every line is parallel to itself but not perpendicular. So therefore this relation is not reflexive. Next we have symmetric. If L1 is perpendicular to L2, then L2 is also perpendicular to L1. So it satisfies the property, so therefore it is symmetric. Next we have transitive property. So if L1 is perpendicular to L2 and L2 is perpendicular to L3, then L1 and L3 are not perpendicular but they are parallel. Therefore this relation is not transitive. So we have seen from this that R is equal to LM, where L is perpendicular to M is symmetric but neither reflexive nor transitive. Next activity is to explore the principal value of the function sine inverse x using a unit circle. To understand this, first let me tell you how to find the coordinates of a point on the unit circle. So we have drawn x and y axis and a circle, unit circle. Unit circle means radius 1, and we mark these points A, B, C, D whose distance is 1 from origin, that is, this is the radius. Taken a point P on the unit circle. So how to find coordinates of this point P if it is making an angle theta with the positive direction of x-axis? To find it, draw a perpendicular on OX. Let this point be Q. As we know, to find a point we have its x coordinate and y coordinate. X coordinate is its horizontal distance and y coordinate is its vertical distance. So we'll find OQ and PQ. So in triangle POQ, let's find cos theta. Cos theta is equal to base over hypotenuse. OP is 1 because it is unit circle. Cross multiplying OQ is equal to cos theta. So its horizontal distance is equal to cos theta. Similarly, we can find sin theta, that is perpendicular over hypotenuse. Again OP is 1. Cross multiplying PQ is equal to sin theta. So its vertical distance is measured by sin theta. So its coordinates will be cos theta and sin theta. So now onwards, if we are given angle, then no need to draw this perpendicular or this point. We can directly find its x coordinate and y coordinate. Let's move to activity. Drawn two rails perpendicular to x-axis at this point A and C. Taken a point P1 which is making angle theta 1 with the positive direction of x-axis. This we have taken a wire which is perpendicular to these rails or is parallel to x-axis just to find this point on the y-axis, because this point gives us y coordinate, that is this distance, and you can see it always lies between 1 and -1 because D has this -1 and B has this y coordinate as 1, and our function is y is equal to sin x. So its vertical distance will be equal to sine of this angle, that is sin theta 1. Now let's take a point in the second quadrant which is making angle pi minus theta 1 with the positive direction of x-axis. So its vertical distance will be equal to sine of pi minus theta 1, that is sin theta 1. As you can see, this line is perpendicular to this rail or parallel to this OX, so these distances will be same. So from here, the points we have taken in the first and the second quadrant with two different angles, theta 1 and pi minus theta 1, we have got the same value, that is, in this case also we have sin theta 1, in this case also we have sin theta 1. As for two different angles we have got the same value, so we say that this function is not 1 1, it is many 1. Let's take a point in the fourth quadrant which is making an angle theta 2 towards negative side. So its vertical distance will be sine of minus theta 2. So therefore y3 is sine of minus theta 2, which is minus of sine theta 2. Let us take one more point in third quadrant which is making angle pi plus theta 2. This is pi, this is theta 2. Then its vertical distance will be calculated by sine of pi plus theta 2, which is equal to minus sine theta 2. So again in the third and fourth quadrant we have seen for two different angles we have got its same image. So it is not 1 1 in third and fourth quadrant. Now let us take all the points on right side. Right side means in the fourth and first quadrant. Let's name these points P5, P6, P7 and P8. For the angles minus pi by 2 to pi by 2, we have different values of sine. You can see this vertical distance in each case is different. You can see from these points, because these points gives us the vertical distance. Same is written here. And the first and fourth quadrants, for any angle minus pi by 2 to pi by 2, we get different values of y in minus 1 to 1, because y will get from minus 1 to 1. So therefore this function is 1 1 in the fourth and first quadrant. Also, if we take any value from minus 1 to 1, any value anywhere, then we'll get some angle theta which will lie between minus pi by 2 to pi by 2. So therefore it is on 2 also. So this function y is equal to sine x is bijective with the domain minus pi by 2 to pi by 2 and range is equal to minus 1 to 1. So if a function is bijective, then its inverse exists. That's where we can say sine inverse exists, and then domain of the function becomes the range of its inverse and its range becomes the domain of its inverse function. So therefore domain of sine inverse function is minus 1 to 1 and range is equal to minus pi by 2 to pi by 2, which is called principal value branch. I hope it is clear. Next activity is to verify that for a function f to be continuous at a given point x0, delta y is equal to modulus of f of x0 plus delta x minus fx0 is arbitrarily small, provided delta x is sufficiently small. In your practical file, this is proved generally without any function given, but then there will be problem in finding observations. So where you put values of delta x. Therefore, I have taken this y equal to root x, whose graph is similar to the graph given in the book. So let's proceed. Drawing x and y axis, drawing graph of this y equal to root x, which is of this shape. Then we take a point A which is at a distance of x0 from origin, and corresponding point on the graph is P. Its horizontal distance is x0 and its vertical distance, this one, is y0, which is at a distance of delta x1 from A. That point is m1. So its x coordinate will be x0 plus delta x1. Accordingly, its point on the graph is n1. So its x coordinate is x0 plus delta x1 and its y coordinate will be y0 plus delta y1. Draw a line from P to this m1 n1 and name it T1. Now you can see this AP is equal to m1 T1. m1 n1 is y0 plus delta y1 and m1 T1 is y0 because it is equal to AP. AP is y0. So this is also y0 and this total is y0 plus delta 1. So this part is y0 plus delta y1 minus y0, that is delta y1. So this part is n1 T1 is delta 1. Similarly, we'll take another point which is delta x2 distance away from x0. This delta x2 is less than delta x1. Accordingly, points are m2 whose x coordinate is x0 plus delta x2. Accordingly, n2 will be x2 plus delta x2 comma y0 plus delta y2, and this n2 t2 will be delta y2. Similarly, we are reducing this delta x. First we have taken this delta x1, then we took smaller this delta x, that is delta x2. Now we are taking or reducing its value to delta x3. Accordingly, we are writing m3, that is x0 plus delta x3, n3 and delta y3. Okay, similarly we are reducing further, that is delta x4, which is less than delta x3, and delta x5. Also we are taking delta x6, which is we are subtracting from x0. This x1 to x5 we were adding in the x0, and this delta x6 we are subtracting to x0. So this is less than this y0. Accordingly, because x0 minus delta x6, then change in y will be y0 minus delta y6. So from this you can see, as we are reducing this delta x from delta x1 to delta x5, similarly this change in y is also reducing. Okay, it is also decreasing. This is delta y5 and this is delta y6. Now let's put some points. Let's write the observation table by taking few values. Our function is y equal to root x. Let x0 is 4, and by putting this 4 over here we'll get y0 equal to 2, because square root of 4 is 2. Now let's take change in x equal to 2. Then how to find change in y? We'll put in this function, that is f of x0 plus delta x1 minus fx0 modulus. x0 we have taken 4 and y0 we have taken 2. So f of 4 plus 2, 6, and minus fx0, that is f4. f6 is root 6, f4 is root 4, root 6 is 2.449, root 4 is 2. So subtracting this and getting the positive value 0.449. So similarly we can find delta y2, delta y3, delta y4 and so on by reducing this delta x. So I have made this table where delta x1 is 2, then 1.5, then 1.25, and reducing it till 0.1. You can reduce further also. So similarly we have got delta y1, delta y2, delta y3, like we found here, this delta y1. The same value is written over here. So you can see delta y is also reducing as this x is reducing. So therefore, as seen from observation table, this delta y is becoming extremely small, provided delta x is sufficiently small. So this we have seen by doing this activity. I hope you understood this. Next activity is to understand the concept of local maxima, local minima and point of inflection. So first of all, one should know what are increasing or decreasing functions. Let's take a function, that is general function, drawing x and y axis. Let the graph of this function from a to b is like this. So you can see from a to b this graph is increasing. We call this as increasing function. And theoretically we write f dash x positive. What is f dash x? It is the slope of tangent. So if slope of tangent, that is f dash x, is positive, we call the function as increasing function. Now suppose from b to c it is going steady, that there is no change, that is f dash x is 0. Then we don't say it is increasing or decreasing. After this, from c to d, this function is decreasing. This we call decreasing. And theoretically f dash x is negative. So I hope you understood, this is increasing when f dash x is positive and this is decreasing when f dash x is negative. Where f dash x is 0, we call these as stationary points. Using this, we'll find maxima, minima and point of inflection. Let the function be fx. So we'll check if at any point there is first increasing then decreasing, then there will be maxima. If first decreasing then increasing, we call it point of minima. Let's draw the graph. Suppose graph of this function is like this. Let's point out our stationary points. Stationary points are where f dash x is 0, that is slope of tangent is 0. So let's mark them A, B, C, D and E. Now let's check at these points whether there is minima or maxima. Just see at A, before this point A, this function is decreasing, and after this it is increasing. First decreasing and then increasing. Then there is minima. So at A there is minima. You can see this is A is the minimum point among these points. Okay, so this is called local minima. At B, before B this function is increasing, after B this is decreasing. So first increasing then decreasing, we call this as a local maxima. Next at C, before C it is decreasing, after C it is increasing. So we call this point of local minima. At D, first before D it is increasing, after this also it is increasing. That means here f dash x is not changing. That is, there is no change. Earlier it was like first increasing then decreasing. Here first decreasing then increasing. First increasing then after this also increasing. So this is called point of inflection. Next at E, first increasing then decreasing. So this is point of local maxima. So we have local minima at A and C. Yes, we have done this. Local maxima at B and E. Yes, now we have understood this. And at D there is point of inflection. I hope everyone understood this. Next we have to construct an open box of maximum volume from a given rectangular sheet by cutting equal squares from each corner. Again we need to take its dimension. Here we have taken a rectangular sheet of length 20 centimeters and breadth as 10 centimeters, and we have cut squares of side x from all its four corners. So you can see x and x, 2x has been cut from the length, so remaining length is equal to 20 minus 2x. Similarly 2x is also cut from breadth side, so remaining breadth is 10 minus 2x. Then after we'll fold this as a box without top, something like this, whose length is now 20 minus 2x and breadth is 10 minus 2x and its height is x. So its volume is 20 minus 2x, 10 minus 2x into x, that is length, breadth and height. After solving this we got this expression, that is 4x cube minus 60x square plus 200x. Now in the activity we have to put various values of x and we have to check where we are getting maximum volume. And maximum volume we can find with the help of formula also, that is second order derivative method. In that we differentiate this expression, we equate to 0, we find values of x. In this case it is 2.1 and 7.9. 7.9 we have to reject, because if we cut a square of side 7.9, then from the breadth part, portion which will be cut will be equal to 15.8 approximately. But total side is 10 centimeter, so we have to reject this. So therefore taking x equal to 2.1. After this we find double derivative and we put this value in this expression. If it is negative, we call this is the maximum volume. If it is positive, we call it is the minimum volume. But in this case it is negative, so we have maximum volume at x equal to 2.1. I hope all of you have understood all the activities. These were 5 activities. I'll try to make another video in which the rest of the 5 activities will be there, so that you can understand all the activities. Alright then, thank you for watching.